Swayam Prabha. Digital India. Educated India.
Welcome to the 17th lecture in the open course on diffusion in multi-component solids. In this lecture, we will see how to convert a set of multi-component interdiffusion coefficients with respect to one dependent component to that with respect to another dependent component. I have illustrated this with a quaternary system. To make the derivation more general, I have treated the case with varying partial molar volumes in this particular lecture. In today's class, we will work on kind of an exercise problem which would give you a flavor of multi-component diffusion. So, we have seen in an n component system we need n square interdiffusion coefficients according to Onsager's formalism of Fick's law. However, not all n concentration gradients are independent, only n minus 1 are independent and the nth one is dependent. Also, if we choose the appropriate frame of reference like volume fixed frame of reference, only n minus 1 interdiffusion fluxes are independent. So, essentially we have n minus 1 square interdiffusion coefficients that define interdiffusion in an n component system. Of course, these n minus 1 square interdiffusion coefficients are functions of composition. At any given composition, which component can be selected as the dependent component is our choice. Now, the set of interdiffusion coefficient that we determine with respect to one component as the dependent component can always be converted into the set with respect to another dependent component, and that is the exercise that we are going to do today. We will look at the quaternary system. So, the problem is you have to convert Dij tilde superscript 4 to Dij tilde superscript 3 for a quaternary system. A quaternary system means we have 9 independent interdiffusion coefficients at any given composition. Dij tilde 4, as you know, denotes the set of interdiffusion coefficients with respect to component 4 as dependent. Dij tilde 3 is the set of interdiffusion coefficients with respect to component 3 as the dependent component. So, if we start with component 4 as the dependent component, we have 3 independent interdiffusion fluxes J1 tilde, J2 tilde and J3 tilde, and those can be expressed in terms of 9 interdiffusion coefficients as minus D11 tilde 4 dou C1 by dou x minus D12 tilde 4 dou C2 by dou x minus D3 tilde 4 dou C3 by dou x. J2 tilde is equal to minus D21 tilde 4 dou C1 by dou x minus D2 tilde 4 dou C2 by dou x minus D23 tilde 4 dou C3 by dou x, and J3 tilde is D31 tilde 4 dou C1 by dou x minus D32 tilde 4 dou C2 by dou x minus D33 tilde 4 dou C3 by dou x. So, there are 9 interdiffusion coefficients with respect to component 4 as dependent component. Suppose we have determined the set of interdiffusion coefficients at a particular composition treating 4 as dependent, and now we need to use it somewhere else, but now we need to treat component 3 as dependent component. So, how do we obtain or how we convert from one dependent to the another? So, since we have to treat now 3 as dependent, right, we have to get rid of the concentration gradient of 3 and obviously the flux of 3 and introduce the flux of 4. So, to get rid of concentration gradient of 3, we can use the constraint sigma Vi bar dou Ci by dou x equal to 0, right, which will yield dou C3 by dou x is equal to minus V1 bar over V3 bar dou C1 by dou x minus V2 bar over V3 bar dou C2 by dou x minus V4 bar over V3 bar dou C4 by dou x. And also we have, if we use the volume fixed frame of reference, the constraint on the fluxes is sigma Vi bar Ji tilde equal to 0. So, we can substitute J3 tilde as J3 tilde equal to minus V1 bar over V3 bar J1 tilde minus V2 bar over V3 bar J2 tilde minus V4 bar over V3 bar J4 tilde. Okay, so now let us substitute, let us take the expression for J1 tilde and substitute for the gradient of 3. So, we get J1 tilde is equal to minus D11 tilde 4 dou C1 by dou x minus dou 12 tilde 4 dou C2 by dou x minus, if we substitute for dou C3 by dou x, will be dou 13 tilde 4 time bar over V3 bar dou C1 by dou x plus V2 bar over V3 bar dou C2 by dou x plus V4 bar over V3 bar dou C4 by dou x. If we take the common derivatives out, we will have J1 tilde equal to minus D11 tilde 4 minus V1 bar over V3 bar times D13 tilde 4 dou x minus D12 tilde 4 minus V2 bar over V3 bar times D13 tilde 4 dou C2 by dou x minus the 4 into V4 bar over V3 bar dou C4 by dou x. If you want to express J1 tilde using component 3 as dependent, then it will be minus D11 tilde 3 dou C1 by dou x minus D12 tilde 3 dou C2 by dou x minus D14 tilde 3 dou C4 by dou x. So, if we compare these two, we get the required conversion for coefficients of 1. So, we can write D11 tilde 3 is equal to d11 tilde 4 minus V1 bar over V3 bar into d13 tilde 4 d12 tilde 3 equal to d12 tilde 4 minus V2 bar over V3 bar into d13 tilde 4 and d14 tilde 3 is equal to minus d13 tilde 4 times V4 bar over V3 bar. Okay. So, similarly, you can find the coefficients for the flux of 2. So, if we substitute for dou C3 by dou x in the expression for J2 tilde minus d21 tilde 4 dou C1 by dou x minus d 2 tilde 4 dou C2 by dou x, this will be plus d23 tilde 4 times substitute for dou C3 by dou x, which will be V1 bar over V3 bar into dou C1 by dou x plus V2 bar over V3 bar dou C2 by dou x plus V4 bar over V3 bar dou C4 by dou x. So, J2 tilde comes out to be, if we take the derivatives of 1 and 2 common, be minus dou T1 tilde 4 minus V1 bar over V3 bar into D23 tilde 4 dou C1 by dou x minus D22 tilde 4 minus V2 bar over V3 bar into D23 tilde 4 dou C2 by dou x minus dou D23 tilde 4 into V4 bar over V3 bar dou C4 by dou x. Now, we can also write J2 tilde in terms of component 3 as dependent, and if we compare the corresponding coefficients, we get D21 tilde 3 is equal to D21 tilde 4 minus V1 bar over V3 bar into D23 tilde 4 D22 tilde 3 is equal to D22 tilde 4 minus V2 bar over V3 bar into D23 tilde 4 and D24 tilde 3 should be equal to minus D23 tilde 4 times V4 bar over V3 bar. So, these are the coefficients for component 2, and to obtain the coefficients for now flux of 4 will be little more complicated, but essentially we do the similar thing. We need J4 tilde, so we substitute J4 tilde is equal to minus V1 bar over V4 bar J1 tilde minus V2 bar over V4 bar J2 tilde minus V3 bar over V4 bar J3 tilde, and then we substitute for J1, J2, J3 using the extended fixed law. So, we get V1 bar over V4 bar D11 tilde 4 dou C1 by dou x plus D12 tilde 4 dou C2 by dou x plus D13 tilde 4 dou C3 by dou x plus V2 bar over V4 bar into D1 tilde 4 dou C1 by dou x plus D22 tilde 4 dou C2 by dou x plus D13 tilde 4 dou C3 by dou x plus V3 bar over V4 bar D31 tilde 4 dou C1 by dou x plus D32 tilde 4 dou C2 by dou x plus D33 tilde 4 dou C3 by dou x. Now, let us take the respective derivatives out and we obtain J4 tilde equal to V1 bar over V4 bar D11 tilde 4 plus V2 bar over V4 bar D21 tilde 4 plus V3 bar over V4 bar times D31 tilde 4 dou C1 by dou x plus V1 bar over V4 bar D12 tilde 4 plus V2 bar over V4 bar D22 tilde 4 plus V3 bar over V4 bar D32 tilde 4 dou C2 by dou x V1 bar over V2 bar D13 tilde 4 plus V2 bar over V4 bar D23 tilde 4 plus V3 bar over V4 bar D33 tilde 4, and dou C3 by dou x is common and we again substitute for dou C3 by dou x, and this positive sign becomes negative. V1 bar over V3 bar dou C1 by dou x plus V2 bar over V3 bar dou C2 by dou x plus V4 bar over V3 bar dou C4 by dou x. So, again we have derivatives of 1, 2 appearing here, and if we take this common and rearrange the corresponding terms, we will get the equations for conversion of coefficients for component 4. So, if we write that, this is negative, and so we have to compare with, let us say, J4 tilde is equal to minus D 41 tilde dou C1 by dou x minus D 42 tilde 3 dou C2 by dou x minus D 44 tilde 3 dou C4 by dou x. So, D 41 tilde 3 becomes so this negative of this and minus this. So, this will be, if we take dou C1 by dou x common, this is multiplied by V1 bar by V3 bar. So, we obtain V1 bar by V3 bar times V1 bar by V2 bar D13 tilde 4 plus V2 bar over V4 bar D23 tilde 4 plus V3 bar over V4 bar D 33 tilde 4 minus this one V1 bar over V4 bar D11 tilde 4 plus V2 bar over V4 bar into D21 tilde 4 plus V3 bar over V4 bar D31 tilde 4. Similarly, D42 tilde 3 should be equal to V2 bar by V3 bar times this bracket again V1 bar over V2 bar D13 tilde 4 plus V2 bar over V4 bar D23 tilde 4 plus V3 bar over V4 bar D33 tilde 4 minus this one V1 bar over V4 bar D 12 tilde 4 plus V2 bar over V4 bar D 22 tilde 4 plus V3 bar over V4 bar D 32 tilde 4 and D44 tilde 3. There is only one term in dou C4 by dou x, so should be equal to, and there is a negative sign here, V4 bar over V3 bar times V1 bar over V2 bar D 3 tilde 4 plus V2 bar over V4 bar D do 3 tilde 4 plus V3 bar over V4 bar D 3 tilde 4. So, this way now we have obtained 9 interdiffusion coefficients with respect to 3 as dependent component, that is Dij3 in terms of interdiffusion coefficients with respect to 4 as a dependent component. So, we have obtained Dij tilde 3 in terms of Dij tilde 4. So, similarly we can make other conversions, if we want to use component 2 as dependent component, for example, we follow the similar steps and we can convert one set of interdiffusion coefficients into another. So, this we have done by not assuming constant molar volumes, that is, we are assuming that or we are allowing the partial molar volumes to vary. Now, if the molar volume is constant, right, then all the partial molar volumes are constant and are equal. So, if we assume molar volume is constant, then trivially we will get rid of those Vi bar by Vj bar terms, right, and we will get a simpler expression for assumption of constant molar volumes. Okay. Any questions? All right, so we will stop here.